Hello everyone. This video clip is about chapter 5, and chapter 5 is about using join and subqueries. So I don't know how many students have heard join or subquery, but so far the query you made so far is leverage only one table. In other words, it collects data only one table. So, but if you use join, it can collect and you can retrieve multiple tables, which is multiple information source. So let me show you some example of the query you made before. So let's say you made the query like this. Select everything from location. Okay, locations. I'm sorry, I made a typo here. Locations. Then you will collect every column, every row data from locations tables. But if you take a look at location table, then you'll see postal code, city, state, province, and country ID. And in the country ID contains only two length characters, CA, US, JP, IT. But to find full name of those those countries, then you have to take a look at countries, and there are country ID, name, and region ID. So if you see the countries, and let me click by default column is selected there. Let me select data tab. Then you'll see country ID, and you'll see the country name and region ID. So if you don't like to have country ID but country name with location information, what do you have to do? Basically, you have to collect data from two tables, which are locations and countries. But if you don't know, queries SQL you made it so far only collects data from one table. So to make a query to show location ID, country, street address, postal code, city, state, province, and country name at the same row, then you have to make a join query, and that's what you're going to learn through this chapter. So here's the objects. By writing select join query, you can retrieve it in data from multiple tables. Okay, and sometimes you need to make a very complicated query to show the sophisticated result. Then you have to make a subquery, and we will see subqueries, some subqueries in the later this chapter. So the reason make two subqueries is by having select statements as internal or tentative result. Using the tentative result, you can make sophisticated result. So let's move to the next page. There are three types of, mainly there are let's see, there are 5 join, but actually you can consider natural join and join are same. A wiki join is part of natural join, and there are outer join. Okay, and under outer join there is 3 different types of outer join: left outer join, right outer join, and union join is another level of set operator beyond join, but we're going to see the examples of union joins. So let's see the graph. Probably you may see this kind of chart in the first chapter of mathematics textbook. So, well, this is kind of operation when A not B, right? And this is A or B, and this when you want to get returned only the dark area, that you have to use intersect set operator, right? Then it's kind of those kind of concepts quite similar in join. So basically, if you want to get only dark area, you need to have natural join. Okay, and if you want to get only this area, then you have to produce left arrow join. Then what about if you want to retribute this part? This part, you have to make right arrow join, and this is going to be union join. But we don't have a set, but we have tables. We have 11 tables, right? 11 tables, and those tables can be used as a set. So let's say if you want to leverage locations table as set A, and if you want, and then and also if you want to leverage countries tables as set B, that means you can make lateral join query and left arrow join or right arrow join or union join. So the tables and or information source or objects in Oracle database can be used as proxy of set operator. A proxy is set in set operations. Okay, so the way to use query, so let me jump to natural join first, because we're going back to inner join. So this is how to use natural join. So let's make a query like this. So let's take a look at the table first. If you see the countries, then you see region ID, right? And region ID, if you go to region ID, regions, then you see region ID, region name. And what about locations? In the locations table, you can see country ID. So country ID refers country ID in locations refers country ID in countries table, and region ID in countries table refers region ID and region. Or if you see other table like department employees, there is department ID, right? And department ID in employees table refers department ID in departments. And you should be able to find another column in employees which refer a certain column from a table, which is job ID. So job ID in employees refers jobs table, which is job ID. So if you, let's say, if the meaning you make a natural join, you don't need to specify column. You don't need to specify columns in the table, because by run natural join, Oracle it will interpret and try to recognize which columns names are same. For instance, job ID in employees and job ID in jobs, or department ID in employees and department ID in departments. So the condition to use a natural join is the column names in multiple tables need to be same, need to be the same. Otherwise, you can't use natural join. For instance, if there's no underscore in department ID in departments, technically, department ID in employees is different from department ID without underscore. So the name of attributes need to be exactly same to use natural join. Otherwise, you can't use natural join. But if they are same, then you can use a natural join. So let's copy this query and test what result you will get in SQL Developer. Okay, basically, the basic syntax of select statement is select, and you have to specify what columns will be will be shown in the result, and from, and you have to specify information source after from, right? And you can add where condition, but where is optional, so it is not mandatory. But as I already mentioned, you can specify information sources after from. In other words, you can specify information source, region, and countries and location. So let me just use those two join query, uh, which could join countries and regions. Okay. All right. So okay. So let's run this query. By default, I don't specify which column will be matched with which column, because natural join will automatically detect the same names, same attribute names in two different or three different or four different tables. So by default, in the region, not that I'm sorry, not by default. The query SQL developer will recognize which column ID will be same. For instance, region ID in regions. We already know there is region ID, region underscore ID in regions and countries. Okay, so let's run this query. So if you run this query, then you will see region ID, country name, region ID, region name, country ID, and country name. So you can see two tables are combined, right? To show a result, to show the combined result in one result set. That means if you, as long as you have same the table and attribute name, you can make a natural join. So let's move to, okay, so let's go back to inner join. Basically, inner join is part of natural join, but natural join doesn't require column name specified, but inner join, to run inner join query or to make an inner join query, you have to which column will be matched. For instance, region ID and in regions table, and region ID in countries table. So let's make inner join. Select. It's a little different to use it. Select region ID, region name, country ID, country name. Okay, from. So far it's the same, right? Region, inner join. Okay. Join. Okay, so join countries. Okay, and then okay, so I think that's enough. Join on I found a typo. Missing keyword on. Okay, so there are two ways to use inner join. You can define which columns and define how or what columns will be compared. Okay, and there are two ways. You can use using clause or on clause. Okay, so when you use using, you only need to specify column name. For instance, region ID and regions. So if you run this query, then you'll see the same result, because region ID in regions will be compared with region ID in countries. So far it's quite similar, right? The natural join doesn't require the column name, but if you want to use natural inner join, this is the inner join. We can type inner join, or you can skip it. Those will show the same result. So when you run inner join, you have to make sure which columns will be compared. So, but it looks like it's same. Then why we need to use the inner join? Sometimes if there are two or more column names are same in two different tables. Sometimes you may want to specify only one or two columns will be compared. Okay, so in this case, natural join will compare regardless how many column names are same. It will compare all the same name of columns. But inner join, if you use inner join, you can specify column names will be compared. For instance, if you have region ID and country name, but in this case region ID and region name in for this query will not be compared. Well, this is an assumption. Okay. All right. So, and another way to use inner join is on. If you use on, you can specify, you can make more detailed condition. For instance, region ID and regions will be matched if the value of region ID is same with region ID and countries. Okay, those are the same, right? But on operator can make more sophisticated conditions. For instance, like this. Although it will show different result, but on operator, by having on operator, you can make a different, or you don't need to stick with a simplified comparison if the value is matched or not. Okay, so this is another example when you use natural inner join with on operator. Okay, and those three are actually called ANSI command. ANSI stands for, okay, let me show ANSI. ANSI stands for American National Standards Institute. That means that is ANSI format SQL is standardized syntax. So that means that means you may already know there are many different relation databases. Oracle database is just one of relational database. That means there are other relational database, Microsoft SQL Server, MySQL, MyDB, or Postgres SQL, even Access, and DB2 by IBM. Those are relational database. So in ANSI, query is standardized. That means if you have the same structure of table and data, those queries will be compatible with any type of relational database. Okay, it sounds like it's the relational database. They have their own SQL format, although it supports ANSI. Yes, this is right. Oracle supports Oracle-oriented SQL or join query. So let me show the Oracle formatted SQL query. To make the same query, I'm going to make a query will be show the same result of queries I made above here. Okay, select. Let me copy the column names. Okay, and we'll show. I will compare basic syntax of query. So again, you can specify information source after from, right? Oracle supports supports define multiple information source after from, such as regions, countries. But the separator needs to be comma like this, and then you don't need to specify after inner join or join operator. You can specify in where. So Oracle extends use of where clause. You can define how the column will be compared in where clause. For instance, okay, I already have a hint here, right? Region ID in regions will be compared region ID in countries. So it's quite easy, right? And it's quite easier. Well, I think it's easier to understand. If you run this query, then you'll get the okay. Countries ID countries column ambiguously defined. Yes. In this case, you have to, because the query cannot recognize region ID. Region ID will be collected? For instance, region ID belong to regions and country ID, right? Countries. So in this case, you have to specify regions. So region ID will be collected from regions, not countries. But actually, those results are the same in this case. Okay, so. But what if you don't like? What if you don't like? But when you only need to specify which column will be collected. If the column names are same, for instance, region name can found only in regions, right? And country ID can be found in only countries. And just like country ID, country name only belong to countries. So you don't need to specify information source for those three columns. But I recommend to specify tables information source. But will bother if you trying to make if you trying to define information source for every single columns, right? Because you need to type full name of table and comma. But if you don't if you don't like to type wrong full column name, you can specify alias. Okay, RC. So R will be used as alias in this query. Okay, so that means you don't need to type full name of table, right? And here RCC. Okay, this is another use of Oracle SQL, Oracle formatted SQL. So it shows information like this. Or if you really want to compare with region ID and from regions and region ID from countries, you can separate it like this. I'm sorry. C. Okay, so by having this, okay, so I need to type here. By having this, you can compare if region ID in regions and region ID from countries are same or not. Okay, so this is the example of Oracle formatted syntax. And actually, the reason I'm saying Oracle formatted SQL is much easier to utilize is it is easier to make outer join. Okay, but you should be able to make ANSI format or ANSI version SQL and Oracle version SQL at the same time. Well, you should be able to convert from ANSI to Oracle, Oracle to ANSI. Yes. So we're here by natural join, and So if you have using operator in ANSI format, you only need to define which column will be compared, like this. In other words, region name, country name, city, regions, and regions will be compared. Region ID in regions will be compared with region ID in countries, and also country ID in countries will be compared with country ID in locations. But if you have another condition like country ID is the same with US, and order option is first column region name. So if you run this query, then you should be able to make ANSI version which use on operator, not using, and also you should be able to convert those ANSI I'm sorry, ANSI data, ANSI SQL to Oracle SQL. So let me show operator using not using operator, leveraging on operator. Okay, so on operator. Okay, on operator. Regions ID. But basically, using operator is simply compare and if there any match value. But if you use on operator, you can use different operator, equal, less than, or less than equal, or equal to, greater than equal, okay, or unlike, okay. So that means it is possible. It's possible to convert all using or join operator with using sub operator can be converted to on format, but it is impossible to or join query with on operator to using operator. The reason is, again, if you use using operator, it will simply match the value, okay. But in on sub operator, you can have different type of operator, comparison operators. Okay, so countries, region ID, and country ID in locations. So if you run this query, then it will show the same result, but I think I made a typo somewhere. Countries, column name ambiguously defined. So it's time to define table source for columns will be shown in the result. So region name, city, regions, okay, country ID. Now here, well, I have no issue in select, but I have issue in country. So country ID countries will have to be used like this. Okay, so I have the same result, right? Okay, and it is possible this kind of query to using format, but and also it is possible to convert from using to on in this case. But what if you have query like this? It is impossible to convert from this to using format, right? It is impossible. So on join query with on operator has a broader usage than using, and natural as well. Okay, so let's move to inner join. Let's move to outer join. So far we practiced inner join, and basically inner join is part of these operators, right? Because it shows only result will be can be collected from both tables. Let's say this is country and this is region and this is country. The query I made so far shows if the country ID, when the country ID matched from countries and locations, it'll be the result is shown, right? Okay, let me show the data from locations. So there are 23 locations, and it has its own country ID. But and if you go to countries, there are 25 countries. Okay, so there are 25 countries, but there are 23 locations only. That means there are some countries doesn't contain or doesn't have any locations or any branches. Okay, so and also if you see the locations, you'll see some country in some countries there are multiple locations or branches, just like these two. There are, in Italy there are 2 branches, and in Japan there are 2 branches as well, and there are 4 branches in the United States. So if you run inner join, then some countries don't have any locations, will not be shown in the result. Okay, but what if you want to see all countries, regardless that there is no matter there is branches or locations in the country or not. So you have to use, because you only use natural join will be showed intersect area, you cannot see the country if the country don't contain any branch. But if you use auto join, then you will see the countries, no matter the countries have branch or not. Okay, so let me show you how to make an auto join. And there are 3 types auto join: left auto join, and right auto join, and full auto join. So left auto join, right auto join is kind of relative. And let's say if the region is defined at right at from, then region will be left part. In other words, countries will be right part. What if you change the order like this? In this case, countries will be left part, and regions will be right part. So the left outer join and right outer join doesn't always show the same result. It depends on which table comes first. Okay, so let's say let me make a query based on this one. Okay, so far if you just don't type inner, you can skip the inner join, right? By default, even if there is no inner, then the query will be recognize the inner join. But to make outer join, you have to type outer join. Okay, outer join. But again, there are 3 types of outer join. Okay, outer join, left outer join, right outer join, full outer join. And in this case, you have to specify which outer join will be executed: left, right, or full. So let me make 3 versions of outer join. Okay, left, right full. So if you see the countries and regions, okay, let me show the regions. There are 4 regions, right? And region ID 1, 2, 3, 4. And if you go to countries, then you will see there are some all the countries belong to at least one region, right? 1, 2, 3, or 4. So we don't see any region. Any region doesn't contain any country. I guess it's not a good example to make outer join. It's better to make outer join with location and countries, because there are some countries like okay, let me see India. Okay, so let's see what country doesn't have any branch. Maybe Kuwait, KW. Yes, I don't see any Kuwait in locations. So I'm going to make left outer join and right outer join and full outer join on locations and countries. Okay, so let's modify countries. And locations. So because I changed the query and table, I can't use region ID country. Okay, let me make a query again. Just okay. Select country ID, country name, and location ID, street address, city, state, province. And postal code from countries left outer join locations on using country ID. Alright, so let's make a query like this. Then okay, street. Alright, so this query shows country ID, country name, and location. So as you can see, Argentina, and Belgium, the countries is shown in the result, right? And because there is no location or branch in those 2 countries, values for street address, postal code, city, and state province is null, because that can't this database cannot find any locations under the country. Okay, so far we have 34 rows, and as you can see in the United States there are four locations. So the countries has at least one locations is not different from the result of left outer join is not different from result by inner join only for the countries which have at least one locations, okay, or 2 more locations. But it is totally different. Belgium, Argentina, and Denmark, Egypt, those countries actually weren't shown in the result by inner join. Okay, so let me make another query which use inner join. Okay, inner join. Okay, so let's see the result. We don't see Argentina or Belgium or Egypt, right? And there are only 23 rows. But what if we disquery? We will see more countries and more branches. Okay, so let's make a right arrow join. Okay, and that means if you run arrow join regardless of countries, all locations will be shown, right? All locations will be shown. Countries, mm, some countries may not be shown. Okay, so if you run this query, then you will see this. You have the same result of inner join. The reason is okay. So if you look at the graph here, this is the outer join, right? Left outer join. I ran right outer join. That means regardless of countries, locations will be shown in the result, right? And there is no location doesn't have any country ID. All locations belong to country ID. This is the result of right outer join. So, and this is why I have same result of inner join. But if you run left outer join, then you have more row. But what if you modify? What if you modify a little bit outer join, and let me change the order on location and countries. Okay. So in this case, right part will be country, and this is the country will be left part in this query. So because country is located right side, right side, and that means regardless locations, all countries will be shown in the result. So right outer join. I think I selected some part. So yes. Again, Argentina, Belgium, and those 4 countries are shown in the result because I executed right outer join on countries. Okay. So and what about full outer join? Full outer join. In this case, you'll see the result regardless of countries and location, regardless of no matter the matching value in those 2 countries. But actually, if you run this query, then you will have the same result of left outer join because again, we don't have any location. Any location doesn't belong to any country. No country. So all the locations belong to at least one and just one country. And if you run this query, then you'll have 34 rows. Okay. All right. So so this is the usage of outer join. But what if you want to make Oracle? Those are ANSI format outer join. What if you want to make Oracle version outer join? You have to. Okay, let me copy of this part, and let me make left outer join first. So the order of tables after from, decide left or right, and then again you can specify condition, right? Country ID is same with country ID in locations. So this is inner join, right? This is inner join. But what if you want to make a left outer join? So if you want to make a left outer join, you have to type like this, plus symbol in parentheses. So this is going to make left outer join. Okay, column ambiguous. So I need to specify, and to specify column table name, I'm going to use alias. Okay, and C L C C L L L L L. Okay. So see, that result is same with left outer join, right? But I needed to place this symbol in right side. So it could be a little confused, but you have to remember, if you want to make Oracle version join query, then you have to put opposite location. I need to put this symbol in opposite location. Then you can make left outer join or right outer join. Okay, so this is a right outer join. So it's quite easy to utilize, right? What about full outer join? Then you may think you can type like this, right? But actually, Oracle doesn't support full outer join. Oracle only support left or right outer join. So to make a full outer join, you have to use another operator, which is set operator. Okay, and there are set operators like the union, or, intersect, and minus. And this operator is, okay, let's see, okay, it's ready. So let's say there are, okay, let me draw a pen. Okay, let's say there are two sets, and let's call area A, B, C. Okay, there is two sets. There are two sets like this. Okay, so it's too small to recognize. And again, there are four set operators. So if you union 1 and 2, then result will be A, B, C. Intersect area only shown one time. Okay. What about union all? It will shows to A, B, and B again, C. That means union or will be show two times the intersect area. So final result will be A, B, B, C. What about A intersect 1 intersect 2? Then only B will be shown, right? What about minus 1 minus 2? A will be final result. So when you need to, well, I think it's intersecting minus is quite easy to understand, but sometimes union and union or may make you confused. But you have to remember union or will show the duplicate result. So it's So you shouldn't be confused with union and union or. So using union and union or operator, you can make full outer join, even though Oracle syntax doesn't support full outer join. So to make a full outer join, you have to basically set operator can be used to combine two results. But to combine two results, the number of columns in the two different results have to be same, and the data type also needs to be same. So union, let's make this is right outer join, right? And let's make left outer join. And this is left outer join, this is right outer join. And to operate, to run two set operators, two result, you have to mix those two query, and then you can specify which set operator will be used. So basically there's only one semicolon here. Though that query looks like long and longer than your queries, your previous queries, but actually that is just one query. So if you run this query, then basically I did union operator, right? Again, union operator shows A, B, C. If there is an intersect area, any intersect area like B, then B will be shown in just one time. So using this query, you can make full outer join, right? This is how to make a full outer join using Oracle format. All right, so sometimes we only used two different tables, right? But it is possible to join the same tables. Sometimes it is possible, and sometimes you need to do. For instance, if you go to employees, then there is manager ID, right? And let's go to data tab, and you have employee IDs, right? And if you go the column manager ID, then you will see the number, and those numbers are their managers employee ID. So to find who is managing which employee, you have to join manager ID and employee ID. And when you need to make a join with with the same table, it is called self join. Okay. So but to make a self join, you have to use alias. Sometimes you don't need to define alias to make inner join and left inner join or outer join or inner join, but to make a self join, you have to use it. Otherwise Oracle cannot recognize it. For instance, so let's say you don't have alias like this. So let's see this query. So I don't have, let's say I don't have alias employees inner join employees. Again, employee ID cannot find which employee ID will be compared with manager ID. For instance, there are two temporary which is loaded on the memory area. So because you don't have alias name for two different, actually those are same, but two different tables. Basically Oracle cannot track which table will find employee ID, or which table will find manager ID. So this is why you have to define alias whenever you make a self join. So by having E and M, employees manager ID from employees will be compared with manager ID's employee ID. So again, this will be used as find manager ID. This will be used to find employees information, and employees manager ID will be matched with manager's employee ID. So by running this query, then you can get employee name and manager name. King manages 2 employees, and Coughlin manage Rogers, and Burgers manage Lodges. Okay, so by having this query, you can make a sample join. Regardless, it is ANSYS style, Oracle style. You have to use alias to make a self join. Alright, so and sometimes you can make a non-equality join, but it is only possible when you use Oracle style or ANSYS style with using operator. Okay, if you just simply use natural join or ANSYS style with on operator, you can't make a non-equality join. Okay, so this query shows employee last name and okay. I need to modify a little bit from employees and grade. I don't have grades yet. Okay, this won't be cannot be executed with our table. We don't have a grades table yet. So let's say there is okay. So if you want to try using jobs and employees, and if you see the jobs, there's minimum salary, maximum salary. Okay, and if you go to employees, there's salary column. So let's say if you are interested to find out whose find employees whose salary is out of minimum salary or maximum salary by the job class. But I think there is no employee like this. So select first name, last name, and whenever you make join, I will always recommend to define the alias for the table name. Employees E, jobs J. Okay, so because I have alias, it's better to define. It's better to use alias. Salary in salary J max. Okay, where is salary greater than J's max salary. Or employee salary is less than minimum salary. Well, I expect there is no employee like this, but let me try. I need to have semicolon. And where's the typo? E salary. Oh, here. I made a typo here. So let's run this query then. Minimum salary. Okay, less than minimum salary maximum. Okay, so it's strange. Yes, I have a lot of employees whose actual salary is out of minimum and maximum salary. So let's see there. Kevin Morgo's salary is greater than maximum. Oh, I'm sorry. I need to compare their subclass. And their subclass needs to be the same, right? And when their employees sub ID same with job ID in jobs table. Okay, so I'm have condition like this. So I don't think yes, I don't have any employee. Or what about I have a little loosened condition like this, greater than or equal to or less than equal to. I have employees whose employee salary is located in the boundary of the range 9,000. Daniel, he received maximum salary in his job class, and Karen, she received the minimum salary, and Martha received the minimum salary, and Randall receives minimum salary in her job class or his job class. So as you can see, you can make an equality operator or comparisons if you make Oracle style join query. So this is why Oracle style query is preferred if you use Oracle database. But if you need to make a compatible query for different type of relational database, when so for instance if your company operate different type of relation database at the same time with but your data set is schema the same, then you have to make definitely you have to make ANSI style query rather than Oracle style, because the query Oracle style query is not guaranteed to execute it on the other relational databases. Okay, so let's RTC and join. Yes, here's the subquery. This is the last part of our PowerPoint slide. So subquery you can by so far we just used we compared two different or multiple tables at the same level, but sometimes you can make tentative result and to leverage to compare the tentative result with upper level query. In this case, the subquery, the uh, internally executed query is called subquery or embedded query. And there are two types of subquery: non-correlated, that means execute once for the entire outer join, and correlate, executed once for each row written by outer join, outer query. So let's compare the subquery first. Let's see some subqueries. So let's say let me run this query. So if you run this query, then you will see the employee's first name and last name and their salary there. If employee's department is null, we may not think there's no employee like this, but there is one employee, friend Kimberly. Her she doesn't belong to any department. She doesn't belong to any department. Okay. So this is a general select statement you made it so far. But what if you want to? So let me ask this question: what if you want to collect maximum salary in each department? In each department, and his or her last name and first name. You may think why I think it is impossible. if you use group function, then you should be able to, right? Let's make group function first. I want to see employee salary and employee first name and last name in if they earning the maximum salary in each department. Okay, from employees, where, well, just define group by first name, but basically I want to see first name, salary, and I'm sorry, maximum salary in each department. Okay, and that means I need to see department. Do you think that is enough? Obviously you'll have error. Okay, the reason is, again, invalid identifier. Well, in this case that means ID, I'm sorry, not in group by expression. That means first name and last name needs to be located after group by, just like a department. Okay, so to avoid syntax error, if I copy and paste here, the result is not is different from what you expected. You will see all employees. Again, we have more than 7 employees, right? So if you simply run this query, then every employees is earning maximum salary in this criteria: first name, last name, and department. This is what sometimes you need to make subquery. Okay, so what I want to see is employee's first and last name and his or her salary if the employee earns maximum salary in each department. To make this query, to show the result, you need to make subquery. So to make a subquery, you have to make get department ID and maximum salary in the department, and you can compare. Okay, so you can compare individual employees' salary is met with maximum salary in department, and you can make it. So this is the logic of subquery. So let's make query first to show maximum salary in each department, but this query will not show employees' first name and last name. Alright, select max salary department ID from employees group by depart ID. Okay, so this will show the maximum salary and department ID. So this this query will be embedded in upper level query. How? Select, let me indent it. Select first name, last name, and salary from employees is E, and this subquery will be used as information source. So that's why I didn't tell table is the only information source. You can use different type of object or a tentative result. So this will be used as a tentative information source. So let me call this, to make a tentative information source, you need to you need to use parentheses. So this part will be this part will be information source, secondary information source, and it has as alias. And then you can define if employees salary the same with salary, maximum salary, okay, and maximum salary. From S, and also you can compare employees department ID and salary department ID from S. So if you run this query, then you get, okay, column ambiguous defined. Where is, yes, E. Need to type E here, here, and here. So they are employees who are making highest salary in each department. So let me type department ID. So department here, right? Let me order by department. Order by 4. So fourth column will be ordering criteria, or you can type department ID instead of number 4. So I have like this, and I have 10 department 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. And what if there's multiple or 2 or 3 3 employees whose whose salary is the same with the maximum salary in the department? All the employees will be shown according to this query, because the condition for this is their salary needs to be met with the maximum salary of each department, and they have to same with the department ID. Then, regardless how many employees making high salary, all the employees will be shown in the result by this query. Okay, so this is a usage of subquery. Okay, and you can locate subquery in from or where it's possible. And this is the result example when you use subquery in where clause. Okay. So in this case, this subquery is nested in where clause, right? Department's name is dummy. That means there is no department ID will be collected, and no ID will be collected. No employees will be shown because there is no employee ID. Like no. Oh, actually there is. So the reason we make a dummy, just dummy, is to have null value, right? And null value if employees department is there is any employee is not doesn't belong to any department will be shown in the result. So this is why these two queries located in one PowerPoint point slide. So when this will be show the employee if their department ID it is null, right? Is null, and this will show, okay. This okay, so this has different. Just let me okay. Well, I guess let me run this query I think it's null. Yes, null and no records is different. So this is why. Or you can make not in. Department ID, departments not in. Okay, this now let me compare, because null is recognized a value as well. So this will be show. This query will show 106 employees, although we have 107 employees, right? But if you run this query, I'm going to collect department ID first, and then with this subquery, the upper level query will show last name, first name, their employee salary, if the employee's department belong to the subquery here. So I need to have 106 employees. Still, Kimberly grants are not shown. Kimberly grants is not shown, neither this query nor this query. Okay, so like this you can make the query. So I think this example in textbook is a little different. Has the wrong result. So sometimes, well, the textbook is not correct anyway. So this is how to make non-correlated query, because upper level query for this case doesn't affect to nested one, right? Only the nested ones executed first, and the nested query will be used as material for the upper level query for this thing in this query. But correlated query, I don't recommend to make a correlated query. The reason is nested or lower level query will affect to upper level, and upper level query will affect to nest query as well. For instance, this is another version. Okay, another version to get maximum salary. So maximum salary, this query. Let's compare the query I made here. This is the non-correlated query to get to show highest honor in each department, right? And as you can see, this doesn't have any alias from upper level query, but this one has select an alias from upper level. Again, if you have non-correlate, benefit of non-correlate query is you can test it. It's easier to test the nested query. For instance, you just need to select this part, and copy it. And if you paste here, and it's easy to test if the inner query works correctly or not, right? But if you copy the nested query from correlate subquery, copy. Okay. It is impossible to test nested query in correlate query. So it should have error because A1 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 in subquery is not defined, unlike subquery in non-correlated one. So E1 compares department ID, and let's see the query first. First, to get the maximum salary, it compares employees department ID in nested one in department ID from upper level. So that means query will be correlated, and in other words, it is hard to test the nested one. but in the name, in the performance, it shows better one. That is mostly, not always, mostly this query it shows a little slower response time, but this one has faster response time. But the demerit of correlated query is it is hard to test if the nested part correctly work or not. Okay, so this is a correlated subquery, and I think I covered almost everything of this chapter. And you can, if there's any missing or any part is not fully understood, then you can ask anytime, or you can review by yourself. Okay, so I think this is longest video clip. Well, this is not video clip anymore, but it's the video lecture uh, from by chapter 5. And it may make you a little bored, but I hope you guys keep focusing on video clip or lecture. And thank you for this is it, and thank you for watching video clip, and I will see you in the next video clip. Bye.